Spring Data FHIR or Spring Data Commons implementations for FHIR library. About me, I'm a software engineer, technical lead with more than 10 years of experience. I'm Java course mentor, technical writer, and I have experience in the different business domains, including the healthcare, which is a part of the topic today. Here is my context, so if you want to get in touch, please feel free. Today we will talk about what Spring Data Common is, what FHIR is, and how to create our own Spring Data implementation and make our integration easier and more elegant. This is John, and he always helped me to explain the things when I'm nervous. Spring Data Commons is the project within the Spring Data ecosystem which has well-known implementations such as Spring Data GPA or Spring Data MongoDB, and today we are going to create another one implementation called Spring Data FHIR. John asked his friends from the John's Multiversary to help us explain different key features of the Spring Data Commons. So let's get started. Repository abstraction. What we can say about this John? Definitely he is pretty much abstract and he has a lot of children. That's exactly what we want to know about the repository abstraction. We have a repository interface which is just a container for holding the type of entity and type of identifier of our entity. In the repository component provider, we search for all the implementations and extension of repository interface and add them as bin candidates. Besides that, here we also search for all the classes and interfaces marked as no repository bin and exclude them from bin candidates. Repository interface has a lot of different extensions, and the most probably known child of the repository bin or repository interface is the CRUD repository interface. This interface is the no repository bin marked interface, which provides us a set of methods to make CRUD operations on our entity. As you can see, to manipulate the collections of the entities, it uses iterable interface, which can be sometimes not really comfortable to use. Because of that, we have another one extension of the repository interface. It's called list CRUD operation, and list CRUD repository, and it provides us additional methods to manipulate the lists. Pagination and sorting. Well, this John is definitely splitted by pages and sorted in some way. In this case is by high. So repository interface has another branch of children's, which name it like paging and sorting something repository. And they consume a pageable and sort typed parameters as input parameters. Pageable interface is the interface that provides us a set of methods to manipulate a page of our entities. So we can get the current offset, the page size, we can go forward and backward to our pages. Sorting class is the container of ordering instances. In the same time as order instance is the container for property name which we want to sort by, and the direction we want to use for our sorting, which can be descending or ascending direction. The next key feature called query methods. And this John is definitely looks like a magician, like a wizard. And this is because another well-known name for these methods is the magic methods. Most of you most likely faced these methods in your career, and they usually looks like that. So we have a method that we want to use to retrieve a full entity. We use a parameter such as we want to search by title and description or serial number, and all the filters are specified in the method name. This functionality provided us by the query parser package classes, and the smaller part of this functionality, smaller piece, is the part class. The part class holds the information about property path, which is the name of the property we are filtering by, and the type definition for this property. If we will take a look at the methods we mentioned previously, all these parts of the method name are actually parts classes, will be parsed as the part class. During the construction of the part class, we have a specific validation that checks if the property path is matched to any of the properties that entity has. And if it's not so, we will face an runtime exception. A bigger part of this functionality is the OR part, and it's a container of the part classes. And during the parsing, it checks that each part should be splitted by the n keyword in the method name. And in our method, the OR parse will look like that in the red rectangles. The biggest part of this functionality of the parsing logic of our query method is the part tree. Part tree holds a list of OR parts, and all of them should be splitted by the OR keyword in the method name. The next key feature is the custom query execution. And this John definitely loves to customize the things. The CRUD repositories are not enough for him. The query methods are not enough for him. He wants to have a full control on what he is executing. He wants to use native queries, specify the parameters by himself. Everything should be on his control. And Spring Data Commons give us the ability to provide him this functionality. For example, we can create the methods and use the SQLite syntax inside the query annotation with specification with all the parameters we want to use. This functionality provided by the next key components. The first one is the query annotation, which we use to mark our annotation that will hold the query text. For example, this is the query annotation from the Spring Data Elasticsearch, and it's used in exact same manner as mentioned. The next key component of this feature is the param annotation, and it looks and works pretty much similar to the query annotation, but it's responsible for storing properties for the parameters of our query. For example, we can store the aliases. Here is the example, again from Spring Data Elasticsearch, how this annotation can be used. So we have Elasticsearch query lookup strategy where we implemented the query resolve query method, and we put all the information about this method into the Elasticsearch query method. Inside this method, we get information about the annotation that our method was marked. And in the method called getAnnotatedQuery, we get value of the text inside our query annotation, and it will be used by the Elasticsearch client, which work under the hoods of the Spring Data Elasticsearch and will be executed directly. Spell or Spring Expression Language. This John, first of all, he's beautiful, I believe, and he's cryptic and full of different regular expression, but let's remind ourselves what's actually the Spring Expression Language is. Here is the example of usage of Spring Expression Language with the configuration properties or with literals, and the result of these literals will be put into the fields. And everything that we see in that parentheses, actually the expression. We can use these expressions with our queries because of the classes from repository query package. And the first of them is the spell query context. Spell query context goes through the text of our query and finds all the expression it has using the pattern matching and populates some map with these expressions. And later on, another class from this package called spell evaluator goes through this map and evaluate each expression using the parameter values. For example, we have the SQLite query where in the where section we are using the expression. we are taking the serial number property from the foo entity. Let's suppose we have a foo entity instance with the serial number equal to 1, 2, 3, 4, 5. And after evaluation, our query will look like that. So everything is remain the same, but the where section contains the literal but not the expression. The last key feature we want to discuss today is the auditing. And this John looks like an auditor. He wants to know where the entity was created, who created the entity, and write it somewhere just in case. For example, Spring Data GPA may support auditing columns for our tables, and they will be containing information about the auditor that created the entity and when it was actually created, in the created by and created date columns. This functionality provided us by the next annotations. The first one is the created by annotation, and created by annotation we use when we want to mark the fields of our entity that will be populated by the auditor information. Another one annotation that provides us this functionality is created date. Exactly, we mark our entity field as the created date, and it will be populated by the date and time when entity was created. Another important part of this functionality is the auditor FHIR interface. Implementation of auditor FHIR interface will require us to override the method called getCurrentAuditor, and from this method we should return the auditor which will be actually populated into the field marked as created by. Here we can return, I don't know, hard-coded value, information from the security context, information from the database, whatever. But under the hood, Spring Data Commons implementation will use the class called auditingHandler. We'll check if any implementations of auditor FHIR exist, and if it's so, it get the current auditor populated into the fields marked as created by, and get the current date and populated into the field created date before the entity will be persisted the first time. Well, that's basically it, what we wanted to discuss about the Spring Data Commons. And now let's shortly discuss what's actually the FHIR is, what's the system we want to integrate with. And FHIR is the fast healthcare interoperability resources. It's the well-known and widely used healthcare repository, standardized data and implementation for healthcare data. It's actually really popular in the healthcare projects, and in our project it's also used very, very commonly. So, key features of the FHIR. First of all, it's a resource-based system. So all the information inside the FHIR is split by resources. We have patient resources, organization resources, participants resources, etc. And it has a RESTful API, so we don't have any specific proprietary interfaces, and it's pretty much simple to integrate with. Here is the list of FHIR resources, and there are a lot of them, more than 100. Firstly, I tried to draw all the relationships between these resources, all the dependency between them, but I was too lazy and decided to use this picture, which was actually the title for this section. And this picture is actually a picture of dependency hell anti-pattern. For us, it only means that we want to integrate with a very complex repository, and it has a lot of dependency between the resources. For those who are interested to start using FHIR, here's the slide how you can use it. But what is the problem with FHIR? Let's imagine the case where we have a patient and we know its ID, and we want to retrieve information about this patient. What we're gonna do? Probably we will just call get endpoints and retrieve the information about the patient resource. Nice, we retrieved the information, the JSON about the patient. It has a link to the managing organization, links to the related persons. But what if we also want to retrieve the full information about the organization? Not only the ID. What we're gonna do? Probably we will create another one, get call to the organization resource and retrieve the information about the organization. So far so good, but what if we also want to retrieve the full information about each related person to this patient? Are we going to make few more calls? How many? I believe it's too many calls we will create and retrieve such requirements. Thanks for FHIR implementation and FHIR standard, we have special hints where we can say, here is the patient ID, please give me the information about this patient and include all the related information. In the response, we will retrieve a list of entries where we have the main resource, which is the patient in our case, and we will have also all the related resources marked as the included resources. Sounds great, but such response may be pretty much complex to parse. It's pretty big, it contains a lot of different structures, and as the Java developers, we actually want to have only a simple page of the patients with all the fields and values we want to know about it, correct? Thanks community, we already have covered all these requirements, and we have a FHIR library which covers the serialization, deserialization, HTTP calls to the FHIR repository. It has a list of pages for each of the FHIR resources. Use that special hints that we mentioned about. And the patient class for this library looks like that, and it has all the needed fields, including the link to the managing organization, list of related persons, whatever we need. Great, and that's actually the client code example when we're using the FHIR with filtering. Here is the another example where we use more filtering logic, and as you can see, the code becoming bigger. And let's make some parallel with the relational database integrations. And on this slide, we have a diagram which from bottom to top, we have increasing level of abstraction of different implementation. On the really bottom, we have our relational database. A slightly higher level is the JDBC driver, where we have that connection, statements, result sets that we need to go through, parse all the needed information from there, create our pages, whatever. The higher level of abstraction is JDBC wrappers, such as Spring JDBC or Apache Query Runner, and they already cover some behavior for us. For example, we can just specify the connection, the text, and they will retrieve us a list of pages, and some mapping will be under the hood. And the highest level of abstraction here is provided us by the Spring Data implementation, such as Spring Data JDBC or Spring Data GPA, where we can just specify a method, a query method, and we will return all the needed data, or we can even don't specify anything, put the empty interface implementation, extension, and that's basically it. We will have a full CRUD operations. And let's compare it with what we have in the case of FHIR integration. So we have FHIR repository, we have HTTP clients that we can use directly. We have a FHIR library, which is kind of a wrapper around that HTTP clients. But what about the highest level of abstraction? What if you also want to create such methods like give me please a list of patients, here is the filters I want to use, and we want to specify into query method, or probably some of us even want to use kind of SQL-like syntax and retrieve the data about the patient? I'm personally not, but probably it's a good use case. Yeah, that's actually exactly what we want to create in the Spring Data FHIR implementation. Here is the implementation map, which we want to go through to achieve our goals and create our Spring Data implementation. We will start from the dependencies, and the first set of dependencies we want to add is the Spring related dependency. So we're adding Spring Data Commons for sure. We are adding Spring Context. We want to use injection and stuff. We add in the Spring Boot auto configurable, and we also add the Spring TX dependency, which is a set of the exceptions. Another part of dependency is relates to the FHIR library. We want to build our library, our starter around it. The first dependency is the FHIR structures. For version is the set of podgers we want to use, and the second dependency is the HTTP client we want to use under the hood. The next step, we are going to implement a simple repository. A simple repository is the repository that will be used as the default implementation when we don't specify any query methods, any native queries, but just put the empty interface. So in our simple FHIR repository, we will implement the CRUD repository interface. We need to have a link, a reference to the FHIR client bin and specification of the model type we want to retrieve. So for each of the resource type, we will have a class specification. And also here we implementing all the CRUD operations. For example, on this slide we have a save or update method implemented. On this slide we have find all and find all by ID method implemented. This code is actually a FHIR library specific code, but it's generalized, and for those who is interested in how exactly each method is implemented, I will share the source code. The next step we are going to implement is the repository factory. Repository factory is the class that will be responsible to create our instances of our repository actually. Again, to provide the dependency for our repository, it should have a reference to the FHIR client. Besides that, it also should provide an information about the entity for the Spring context. The entity information, in our case is FHIR entity information implementation, is the container that holds the type of ID entity has and the value of this ID. It actually can be used when we determine whether our entity is new or not. The next methods we need to implement in our repository factory is the getTarget repository, which actually creates the instance of our simple repository using the reflection, using the class from the parent class. Another method called getRepositoryBase class specifies the class information about our repository. And the last method we want to implement here called getQueryLookupStrategy. For now, we will leave it empty, but we will return to it when we'll be implementing more complex things. The next step is the FHIR client default configuration. So this configuration will be used when someone will attach our Spring Starter and start using our library. And here we specify a bin for HTTP client. We are using the default builder from the FHIR library, which consumes only the URL of the FHIR server, and that's basically it. We will mark our bin as the conditional or missing bin annotation to provide more flexibility for our clients, so they can override this bin, they can put some another configuration for a try logic or for serialization or deserialization logic, whatever they need. Repository factory bin. Repository factory bin is responsible to create actually the instance of our FHIR repository and provide all the dependency it needs. And that's actually the place where we take a link to the FHIR client from the Spring context and put it into our FHIR repository factory and finally in our repositories. So because of we want to be able to create our repository factories, we need to extend repository factory bin support and to override the create repository factory methods. And because we want to interact with the Spring context, we need to implement bin aware, factory aware interface and implement the set bin factory method, where we can achieve our bin factory and get all the needed bins from there. In our case, it's only the FHIR client bin. The next part and next set of steps is responsible for enabling our repository and providing a bin definition for it. So the first step is the repository extension creation. Repository FHIR repository configuration extension is the class that provides information about the module name, about the module prefix, and about the factory bin class name. This information will be used with our repository bins, and all the prefix will be added as the prefixes for name for our bins. And during the construction and enabling of the repository, the Spring Data Commons checks if the extension exists because it's part of bin definition, and if it's not, we will face the exception. So this implementation is mandatory. Again, it's a part of bin definition for our repositories. The next step is the enabling annotation and repository register. Enabling annotation is the annotation that you most likely used when you start using some Spring Starter. So you probably face it enabling transaction management or enabling scheduling. And in our case, this annotation will be named like enable FHIR repositories. Inside here, we will import the default configuration and FHIR repository register into the Spring context. Besides that, we will implement few methods: repository factory bin class and repository base class, where we will specify the information about our factory bin, repository factory bin, and default repository class. So it can be a default repository base class from the Spring Data Commons, or it can be our simple repository class. And repository register, FHIR repository register, is responsible to provide bin definition to the Spring context and enable our repositories. It provides information about the annotation class, enable annotation class, and instance of the extension. In the class bin definition reader, we get all the bin definitions from all the registers we have and put them into the context, and later on, based on these definitions, our bins will be created, our repositories will be created. Also, during the register of the bin definitions, we get information from the our annotation, from our enabling annotation, and get it as the configuration source. Also, we get the extension instance, and this is the second part of our bin definition. And we build the final build definition based on these two data sources and return them from the register. Well, we actually successfully implemented all the things, all the steps needed to provide the basic functionality. Now let's suppose we finished our implementation, we built our jar, name it somehow, and how our clients will be able to start using it. So what they need to do, they need to add the dependency to our library. They need to add the enabling annotation on top of main class or not on top of the configuration class, dependent on, I don't know, company rules. They need to specify a base URL for the FHIR client and create an empty interface for any FHIR resource they want. In our case, it will be a patient repository. So here we can use as the base interface any interfaces from the repository hierarchy. And that's actually it. After that, we will have a full CRUD operations on any of the FHIR entity just in few rows of code. Great, now let's continue with implementing more advanced features. Query lookup strategy. You remember our FHIR repository factory where we left a get query lookup strategy method empty. Now we are going to implement some logic here. So we added here a FHIR query lookup strategy implementation and put there a FHIR client as the dependency. In the FHIR lookup strategy, we implemented the resolve query method and returned the implementation of repository query interface. And inside our implementation called FHIR query, we will implement our first advanced feature called query method support. So inside FHIR query class, we have information about the method, we have information about our returning type, we have parameter name list from the method, and we also have a link to the FHIR client. The most important thing we are gonna do during the creation of instance of our FHIR query, we're going to populate the parameter names from the method name. This is how this extracting method looks like. We get the method name, we checking if we have any parameters inside it, and if we have them, we are building the part tree, that class from the query method support. And then we iterate through the part tree, through the OR part which is inside it, through the parts which is inside the OR parts, and going through all the parts, we are populating the parameter names. So it's kind of composite pattern implementation, and as you can remember, building the parts inside the part tree, we also have the validation for the property names. Great. After this method will be executed, we will have a list of all the parameters names we have, and also we need to implement few methods inside our FHIR query. The first one is the execute method, which is actually executes the query, and we put this logic in the separate class called FHIR query executor. And also each query method, each repository actually should know all the information about each query method it contains. This information we return from the get query method and the query method class is the wrapper around the method metadata, and for example we can retrieve the method name from here, we can retrieve the parameters, we can retrieve the result post processor, etc. All the query methods definitions information is stored for each of the repositories in the list. Here is the implementation of our FHIR query executor, where we execute our queries, and the implementation is pretty much similar to what we have in simple FHIR repository in defined all methods, but here we populate the where section, our filtering section, dynamically based on the parameter names and parameter values we're retrieving from the parameters. Again, we will not deep dive here into the Happy FHIR library specific codes, but for those who are interested, this code also will be present in the repository I will share. Next job, now our repositories support the query methods. And next, let's implement the custom query execution. I say that I'm not a big fan of using SQL-like syntax for retrieving FHIR resources, but it's a good use case to show how actually it can be implemented for our cases. And for this use case, we will implement the query like this. So we want to retrieve a patient information, and all the filters will be specified in the where section. We're creating a query annotation and put the value of the query text inside it. After that, we are modifying our FHIR query class and add here additional logic. So we're trying to retrieve a query annotation from the method. If it exists, if our method was marked as the query, we trying to retrieve parameter names from the query text. If it's not marked, if we don't have query annotation, we'll go by the previous implemented logic and extract all the parameter names from the query method. Inside the extract from query method, we have only the simple parsing logic where we get where section, get all the parameters from there and populate the parameter names. That's basically it. After we populate the parameter names, we don't need to implement anything else beside that. The query executor will handle all the rest of the logic for us. That's actually it what we wanted to implement in our Spring Data FHIR implementation. Now our repositories provide a full CRUD operation on any entity. We can create query methods. We can create a native SQL-like queries that will be parsed and executed by the FHIR client. Summary. So Spring Data Commons provide us a powerful tool that can help us to create our own integration frameworks. It can make our lives easier and integrations more elegant and save us a lot of time. But keep it simple. If you already have a simple integration, or if you already have some framework that covers all you need, or library that suits absolutely wonderful for your case, don't try to implement everything from scratch. Don't overcomplicate your project. Thank you for your time. Here is the slides for the presentation slides and source codes, and enjoy a day.